Welcome to another episode of Terry's Notes. Today we are going to be looking at the first video in the mole concept. Now, the mole concept for many students is a difficult topic. Now, my advice to you is not to learn off any formulas regarding the mole concept. What you need to do is to understand the concept itself. Therefore, if the question is asked in a way that you are not familiar with, you can still figure out what is going on in the question. Before we start, we need to go through some definitions that you are required to know. And the first one is relative atomic mass. And relative atomic mass is simply the average mass of one atom of an element compared with 1/12 the mass of a carbon-12 atom. The mass of a carbon-12 atom is taken to be exactly 12.00 units. And if we were to write this mathematically, we can say that relative atomic mass, which is capital A subscript small r, is equal to the average mass of one atom of an element divided by 1/12 the mass of one atom of carbon-12, which we said is exactly equal to 12.00 units. So some examples: if you go to your periodic table, you will see chlorine is written as Cl, which is a symbol for chlorine, and the mass number is 35.5 and the atomic number is 17. This mass number gives you the relative atomic mass, right? So the relative atomic mass for chlorine in this case is 35.5. If we look at sodium, which is 2311, the mass number is 23. So the relative atomic mass is equal to 23. So this information is usually determined or can be found on the periodic table. The next definition we need to look at is relative molecular mass. And relative molecular mass is the average mass of one molecule of a substance when compared with 1/12 the mass of a carbon-12 atom. Alright, now in this first example we have water. The formula for water is H2O, and if we wanted to get the relative molecular mass, what we will do is add up the masses of the actual atoms within the molecule. So we have 2 hydrogen and we have 1 oxygen. So if we wanted to calculate the relative molecular mass, it'll be, before I reach there, hydrogen mass number is 1 and oxygen the mass number is 16. So if we wanted to calculate the relative molecular mass of water, since we have 2 hydrogen atoms, it'll be 2 multiplied by 1 plus we have 1 oxygen atom and we know the mass number is 16, so it'll be 2 plus 16, which gives us 18. So 18 is the relative molecular mass of water. Let's do one a little more complicated. In this case we have glucose, which is C6H12O6. So therefore we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And carbon, from the periodic table, we know that the mass number is 12, hydrogen is 1, and oxygen is 16. So we have 6 carbon atoms, so it'll be 6 multiplied by 12, that we got this 12 from here, plus we have 12 hydrogen atoms, so it'll be 12 multiplied by 1, and we have 6 oxygen atoms, so it'll be 6 multiplied by 16. Okay, so that'll be 72 plus 12 plus 96, and that will give us 180. So the relative molecular mass of glucose is 180. Now notice we don't have any units next to these numbers. So like we have 18 and we have 180, right? Because we are dealing with relative molecular mass, we have no units here. The next formula or the next definition we need to familiarize ourselves with is relative formula mass. Now, relative formula mass is the same as relative molecular mass, but it applies to ions only. So the relative formula mass is the total relative atomic mass of all the atoms in the formula of an ionic compound. So in this example, we have magnesium sulfate. Magnesium sulfate is an ionic compound, and the formula is MgSO4. So we have one magnesium atom, we have one sulfur atom, and we have 4 oxygen atoms. From the periodic table again, we know that magnesium mass number is 24, sulfur is 32, and oxygen is 16. So therefore, if we have one magnesium atom, it'll be 24, plus we have one sulfur atom, so it'll be 32, plus we have 4 oxygen atoms, so it'll be 4 multiplied by 16. So therefore, the relative formula mass will be 24 plus 32 plus 64, which gives us 120. We now come to the definition of the mole, which you need to be able to recall. So the mole is the amount of substance that contains the same number of particles as there are atoms in 12 grams of carbon-12. Now 12 grams of carbon-12 contains 6.02 by 10 to the power 23 carbon atoms. You need to familiarize yourself with this number. This number is called the Avogadro number or the Avogadro constant. Okay, so 12 grams of carbon-12 contains 6.02 by 10 to the 23 carbon atoms, and this is 1 mole. So 1 mole of any substance will contain 6.02 by 10 to the 23 atoms. Now, when we are counting particles, the unit used is a mole, and the symbol for the mole is MOL in lowercase. Alright, and when we use the term particles, particles could mean electrons, it could mean molecules, it could mean atoms. Now let us look at this example. Calculate the number of moles in 80 grams of magnesium. Now remember I said, try not to learn off any formula. You just need to read the question and try to understand what they are asking. So they want number of moles. Now, whenever you have a mole question, whatever they are asking needs to be on the right-hand side of your statement. So we have moles and we have mass in grams. So magnesium from the periodic table has a mass number of 24, right? So that is the relative atomic mass. So therefore, what this means is that 24 grams of magnesium contains 1 mole. Okay? Therefore, now we need to calculate for 80 grams. So 80 grams of magnesium will contain 80 multiplied by 1 over 24, which gives us 3.33 moles. Now essentially what I'm doing here is cross multiplying. Taking the 80 multiply by 1, and then I have to divide it by 24. All the mole calculations examples that we're going to do are going to follow this format. So the first thing you have to ask yourself is, what is the question asking? In this case is moles, so therefore I need to write my statement so that the moles is on the right hand side. Let's do another example. Calculate the number of moles in 24 grams of magnesium sulfate. Okay, so they want number of moles. So therefore, I need to write my statement such that moles is on the right hand side. And we are dealing with an ionic compound here, which is magnesium sulfate. Now, previously we had calculated the relative formula mass of magnesium sulfate to be 120. Alright, because we have one magnesium atom, mass number is 24. We have one sulfur atom, the mass number is 32, and we have 4 oxygen atom, so the mass number is 16, so it's 4 by 16. So we get 120. Now what does this 120 mean? What this tells us is that the mass of 1 mole of magnesium sulfate is 120 grams. Okay? Now I said that we want to calculate the number of moles. So we need to write our statement so that moles is on the right hand side. So 120 grams of magnesium sulfate contains 1 mole. Question asks you for 24 grams. So therefore 24 grams of magnesium sulfate contains, we cross multiply, so we take the 24 and we multiply by 1, and we come and we divide by 120. So it's 24 by 1 over 120, which gives us 0.2 moles. Okay? Okay. In this next example, we have calculate the number of moles in 18.06 by 10 to the 23 molecules of chlorine gas. Okay, so we want number of moles again. So number of moles need to be on the right hand side. Now, we know that 1 mole of a substance contains 6.02 by 10 to the 23 particles. In this case, the particles here is referring to molecules. So we write the statement 6.02 by 10 to the 23 molecules of gas are present in 1 mole of chlorine gas. Okay? We're not dealing with the mass number in this example because we are looking at number of molecules. And we know that 1 mole of a substance contains 6.02 by 10 to the 23 particles. So therefore, question asks you for 18.06 by 10 to the 23. So therefore 18.06 by 10 to the 23 molecules of gas are present in, again, because of how we wrote our statement, we cross multiply. So we take the 18.06 by 10 to the 23, we multiply by 1, and we come and we divide by 6.02 by 10 to the 23. And this gives us 3 moles of chlorine gas. Okay, in this example, we want to calculate the mass of 2.6 moles of sodium carbonate. Now, in this question, you realize they want to find mass. So if we want to find mass must be on the right hand side of our statements. But before we do anything, we need to calculate the relative formula mass of sodium carbonate. Now, sodium, the mass number is 23. And we have 2 sodium atoms, so it'll be 2 multiplied by 23. We have 1 carbon atom, so we add 12. And we have 3 oxygen atoms, so it'll be 3 by 16. Now the 23, the 12, and the 16, you would have gotten that from your periodic table. And this gives us a value of 106. What does this number mean? This number means that the mass of 1 mole of sodium carbonate is 106 grams. Now the question is asking for mass, so I need to write my statement such that mass is on the right hand side. So 1 mole of sodium carbonate has a mass of 106 grams. Question is asking for 2.6 moles. Therefore 2.6 moles of sodium carbonate has a mass of, again, if we wrote the statement like I showed you, you take 2.6 multiplied by 106 and we divide by 1. So 2.6 multiplied by 106 divided by 1, and that gives us 275.6 grams of sodium carbonate. In this next example, we have to calculate the number of molecules in 2.1 moles of hydrogen gas. Now we know, now the question is asking for number of molecules. So therefore, we should write our statement such that number of molecules is on the right hand side. So we know that 1 mole of hydrogen gas contains 6.02 by 10 to the 23 molecules, right? The Avogadro number. Therefore, 2.1 mole of hydrogen gas contains, we take 2.1, we multiply by 6.02, and we divide by 1. And that gives us 1.264 by 10 to the 24 molecules of hydrogen gas. Now let's talk about Avogadro's law. Basically, Avogadro is saying that equal volumes of all gases at the same temperature and pressure contain the same number of molecules, right? And molar volume, if you look at the word itself, molar volume, that tells you the volume occupied by 1 mole of a gas. Now, in chemistry, we'll encounter two conditions. We have standard temperature and pressure, which we call STP, and we have room temperature and pressure, which we call RTP. Now, at STP, the temperature is 0 degrees Celsius and the pressure is 1 atmosphere. And at RTP, the temperature is 25 degrees Celsius and the pressure is 1 atmosphere. So the difference between the two is really the temperature. So at STP, 1 mole of a gas is equal to 22.4 dm cube. At RTP, 1 mole of a gas occupies a volume of 24 dm cube. Now in most questions, they will give you what is STP and RTP, but you should try to remember it. So STP is 22.4 and RTP is 24 dm cube. Now let's look at an example. Calculate the volume occupied by 0.2 moles of carbon dioxide at RTP. Now, RTP, we said room temperature and pressure. We know that 1 mole of a gas occupies 24 dm cube at RTP. And we want to find for 0.2. So we need to write the statement such as the volume is on the right hand side. So 1 mole of CO2 at RTP occupies 24 dm cube. And we want to find for 0.2. So 0.2 moles of CO2 at RTP occupies, we take the 0.2 and multiply by 24 and divided by 1, and we get 4.8 dm cube of carbon dioxide. In this example, we want to calculate the number of moles in 1.2 dm cube of ammonia at STP. Now at STP, we know that 1 mole of a gas will occupy 22.4 dm cube. Now the question is asking for number of moles. So the statement should be written such that moles is on the right hand side. So 22.4 dm cube of ammonia contains 1 mole. And we want to find for 1.2. So 1.2 dm cube of ammonia contains, we're going to cross multiply, so it's 1.2 multiplied by 1 divided by 22.4, and that gives us 0.054 moles of ammonia gas. And our last example, we want to calculate the volume occupied by 34 grams of ammonia at RTP. So RTP, we know is 24 dm cube. And the question is asking for volume. So therefore, volume should be on the right hand side. But because we are dealing with masses here, we need to find the relative molecular mass of ammonia. The formula for ammonia is NH3. So the mass number of nitrogen is 14 and the mass number of hydrogen is 1. So you have 14 plus, we have 3 hydrogen atoms, so it'll be 3 multiplied by 1, and that gives us 17. So what does this number mean? It means that the mass of 1 mole of ammonia is 17 grams. So therefore, 17 grams of ammonia occupies 24 dm cube at RTP, right? Because 17 grams is 1 mole. But the question is dealing with mass. So therefore, 34 grams of ammonia occupies, in this case you're going to cross multiply, 34 multiplied by 24 divided by 17, and that gives us 48 dm cube at RTP. So a lot of students have trouble with mole calculations. Like I said, I don't advise learning off any formulas because you are not sure how the question is going to be asked. What you need to remember is whatever the question is asking, write your statement such that the answer will be on the right hand side, and you simply have to cross multiply in order to calculate the final answer.